Okay, now, and the computer's not ready, so I got to do this, and then, okay. All right. So, if you looked at the calendar, this is blank. I'll put it in later. It does come from 1.6, but I decided not to use the book as a homework. I have a sheet for you, but I'm gonna wait for a second. Go over this fast. Make those that are doing homework. It's okay as long as you get an A plus. Nobody that doesn't listen to the notes is getting an A. Did I say that English-wise correctly? Okay, so whatever. All right, so they look like this. They're graphs and pieces. So the first thing, I stole this off the internet. Shh, a lot of jibber jabbers. People that can't afford it. Okay, here's how the piecewise function looks. It is one function, f of x, defined by pieces. That's why it's called a piecewise function. I'm going to go ahead and color code this. You don't have this in your handout that I'm going to give you, but that's what you need to understand. And I know I did the top one in yellow when I named the f of x in yellow. So as a way of maybe you catching up and taking notes, which I noticed 3 out of 22 are. That's great. Whatever. When does this happen? And I think someone asked me this last week. Hey, I have a phone bill. This is the way phone bills used to work back in the day. A cell phone, way old ones. Just play along. Used to get the cell phone, and then I'm just going to make up minutes. For the first 30 minutes, you get 30 minutes free, and we're going to charge you $20 a month. I know I'm using a low amount of minutes. So, I use 0 minutes. How much do I pay? I use 10 minutes. How much do I pay? So, once you agree that it's this horizontal line, this is my cost function with the money being the y-axis and the minutes I use being the x-axis, right? But after 30 minutes, this kind of works with if you're on a limited data plan, which some may be, we are, because I don't care. We don't need that much data over the spend an extra $40 a month for unlimited. No way. I'm a school teacher. I'm broke. Okay, so after that, each additional, let's say 5 minutes, just to make this, cost an extra $1. So what happens if I use 31 minutes? 32 minutes? 33 minutes? So on and so forth. So what happens is it steps off. This is almost like the greatest integer function. That's what we were kind of talking about. Then we'd have to have an open dot here, and then this is the graph for here. So what this is it's defined in pieces and defined at different intervals to be a different cost function. This could be, even though this kind of emulates the greatest integer function, it also emulates what a piecewise function. For this interval, some scenario is defined by this equation. Then between this interval, the graph is defined this way. And then in this interval, the graph is defined that way. So that's what you need to understand what a piecewise function is. And then I love what they do on the internet because they ask these questions without even a picture. We'll eventually graph. By the way, when you put all 3 of these intervals together, what is the domain of this function? Negative infinity to what? This covers all the numbers from negative, right? What are the numbers that are less than or equal to negative 2? Negative 2 all the way to negative infinity in reverse mathematically, the way we're supposed to think of it. Then all the numbers between negative 2 and 3, not including negative 2. And then all numbers greater than 3, not including. That covers every single number. So actually the domain of f of x is all real numbers. It's all covered. So these are all things you should be writing down as you look at this. I did press record, right? That'd be a good start, because how many times have these movies not worked? Okay. All right, so what's f of negative 4? Hey, what color should I make that for my color scheme?
I was thinking pink too. Purple.
I'm going to throw up. Is it yellow, green, or blue? Oh my gosh, please stop. There must be something in the water. Yellow. So this means negative 4 is actually the first piece. What's 2 times negative 4? Negative 8 plus 8 is 0. What color should I make 6? No silly answers. Oh my gosh. Okay, I'm going to stop. I'm literally going to kick you out. Okay? Blue! Why? Where does 6 fall in this? I press play. Oh, I press play. And I put that thing that I just said in there. I'm going to kick you out. Boy, teaching is easy. Try it! Those that are saying that on the internet, what are you looking at? No, I'm talking to her. Okay. Where does negative 2? Oh, okay. Now this one's okay if you get it wrong. What color should I color that one? It is actually yellow. Negative 2 is in this interval, that top one. This is between negative 2 and 3, but not including negative 2. So what's negative 2 squared? 4. Minus 3. 1. Man, I'm being a jerk today. Hey, what color should I color 0? That's in the green piece of the domain. So that's why I love this that they had on the internet. They really broke this down nicely. So that's in the green. Wait, I colored, what did I do? You guys should have stopped me. Did I make a mistake in the previous one? Thanks. Yellow, which is 2 times negative 2 plus 8, which is actually 4. Ooh, did you see that recovery? Okay, and then this is 0 squared minus 3, which is negative 3. So that's why I like what I stole off the internet. They do a great job of really getting you to analyze that part on the right is actually what the domain is for each piece. But this is one function defined by all those pieces. That's why the overall domain of the function is all real numbers. Now the reason I like this one, if you want to sketch this real quick, and actually I'm going to create something out of this off to the side. Maybe I'll come back to it. We can reverse this and actually come up with what is the piecewise function for this. But that's not what we're going to do right now. What do you think f of 0 is? This is the first graph, second, third. Which graph should I look at in order to analyze f of 0? First, second, or third? It's actually third, because f of 0 is for x. And 0 for x, actually, this is where the graph exists. Now that I just did that, what's f of 0? Oh, man. This is why I like this question, because students don't understand graphing. Graphing are just a series of coordinates. I input 0, and what do I get as an output value? 2. Okay? This is another reason. This is another thing that shows piecewise functions and really gets you to understand what's happening with the domain. Then where do I look at for negative 4? First, second, or third? First. What happens when I plug in negative 4? What do I get? It's actually 1. So I love this. It's really easy to do, but it makes you understand that these pieces are for particular parts of the domain. F of negative 1 is, ooh, careful, first, second, or third? It's actually second. What's the answer? Because this is a what kind of dot? Filled in, and then that's why this is open, because this is like the jump off to the next one, if you think about a greatest integer function. So that open dot means the graph doesn't start at negative 1. It starts right after negative 1 and then goes on. And this is something you need to know, and we'll talk about that with graphing. And then what's f of 3 from the picture? What's f of 3? 3. Very simple. And then we're going to actually graph these. I'm going to come back to this, and we're going to find out what is this function. We're going to reverse analyze it. What? Just made up a word. But not yet, because you don't, we haven't graphed yet. And then I want to pick a challenging one, which I think I might pick this easy one first. Okay, now what is this? Try it. Actually, what they should say is graph it. And I have enough tough ones that I think I'm going to go to this one because it just has a little bit differences going on there. So sorry if you were taking your notes. I don't have to do all of these because they all align the situation just fine. And I want you to get working. I want this video to be uploaded in time before we go. So, okay, f of x equals these two pieces. By the way, what is the domain of f of x if you look at these rules? It is negative infinity to infinity overall. That is the domain of f of x. F of x is defined by these two pieces of this split up domain. But when you put them together, it's all real numbers. Okay? All right. What is this picture? What is this a picture of? So what is f of x equals 5? That is a horizontal line. Now, I don't have to do a chart of values to draw a horizontal line, but I can only draw that horizontal line up to all values that equal to including 2. So, 2, 3, 4, 5. Again, that's why I like our beginning questions, because it establishes the idea of a split up domain. That's what splits up the pieces. And I can graph it for all values that are, sorry for being shaky, less than or equal to 2. Then, what is this a picture of? That is a line. So maybe what you want to do for this is, I think I do better with colors. You could do a chart of values for this, but what do you start the chart with? Do you start it with 2 or do you start it with 3? What do I put for x? Do I put 2? Do I put 3? Which one? Half the people are going to say 2, half of them are going to say 3. The correct answer is 2. By the way, what's 2 times 2? 4 minus 4. So what do I do at 2 comma 0? It's an open dot, just like that previous one I just told you. This was the stepping off point. Then this graph starts just after -1, but we want a starting point to put an open circle there to show -1 comma is not 1. That's the start of the new graph, but after -1 is when I start graphing that. So we need to understand that fully so that we can graph these correctly. All right? All right, so back to that. And then, all right, and then what can I plug in next? 3, or we could do slope. What's the slope of this? 2 over 1. So I could rise 2 and then run 1, and then the rest of this is like this. Is this continuous, yes or no? What kind of discontinuity is this? This is a jump discontinuity. And I told you when we did that back in the backboard, these are rare. The only time we'll see it as greatest integer. Then the only thing I can think of when we deal with graphing is piecewise functions. Now, not as pretty. This is what I've asked for CAT classes, numerous examples. I just have 2 more. One of them is my own creation, not this one. I love the one I created. Love it, love it, love it, love it, love it, love it. Okay, so this is a piecewise function with 3 pieces that define one function. Again, look at the parameters. What is the domain of f of x? Doesn't always have to be this either, but what is this domain? When you connect, if you still haven't understood what I'm saying on this, if you connect x is less than or equal to -2 to -2 not included to 3 included, then not included 3 to infinity, that's all real numbers. Every x value is covered by this piecewise function. Again, I want you to know that so that we can get this figured out. I'm going to do the same thing here. Okay, so the first piece, it doesn't color very good. Okay, so you could do XY charts, but this one's silly. What is f of x? What is f of x equals 1? What is that a graph of? Yet again, horizontal line. Or I plug in, can I plug in -2 for x? Yes or no? What do you get for y? Well, there's nowhere to put anything in for x, so you're going to get 1. It's a constant. I plug in -3, I get what? Plug in -4, I get what? What do I put at -2 comma 1? What kind of dot? -2, I don't know why I'm going down. -2, 1. -2, -3, 1, and so on and so on and so forth. So this is a horizontal line going this way. And it stops right there because the domain tells me to stop there. Then I go to the next graph wrong. The next piece. What is f of x equals 2 plus x? What kind of picture is that? It's a line. Do I plug in, let's color code that green. I just need thicker highlighting, I guess. So what can I plug in? Should I plug in -2, yes or no? Yes, I should, but what kind of dot should it be? Open. Okay, what's negative 2 plus 2? 0. So at negative 2, 0, I have an open dot. This is the step off. So is this continuous, yes or no? Sometimes they can be continuous. One could go right on top of the other. This open dot could accidentally go right on that filled in dot. Then it would be continuous at that point for this piecewise function. Did you hear what I just said? All right, and then what kind of picture is this? It's a line. So couldn't we just do 3? What's 3 plus 2? Because 2 points make a line. And I've always been amazed. Did you do these last year? I've always been amazed how jacked up these are. Like students that don't listen, don't pay attention, whatever, don't do their own thing. Then they just graph all 3 individual pieces as full graphs. And then you got graphs crashing into each other. Okay, I'll show you that on the next one. And you're not even reading and analyzing what this is. Just do it. It's actually really easy. It's really easy. What's that last picture? What's that last piece a picture of? Yet another line. I guess I only have blue left, although I colored. So this is the blue chart of values. And then what can I plug in? Should I plug in 3? What should I put at 3, 6? 1, 2, 3, 1, 2, 3, 4, 5. Is it continuous at this dot? Yes or no? No. Or you could do slope. Rise 2, run 1. And it doesn't look so good because I'm a little shaky with my pen. But if I move in on that, we have 2 different jump discontinuities because they're just barely off of each other. Those pieces could be connected by accident, and then therefore the graph could be considered continuous. Because this is one graph, but you need to understand this is the graph of f of x. It's just a piecewise function defined by 3 different parts. 3 different domains, 3 different equations. And then this is my own devious design. Ooh. Went nuts on you here. What's the first thing a picture of? 2x minus 1. What's the second thing a picture of? Quadratic, which means it's a parabola. What's the third piece? Which is a picture of a V. And we might need to know something about vertex in order to know where this is located. Okay, so in the most beginning ways of doing this, this is how you do it. Okay, first piece, defined by this. So what should I put in this chart? What number should be first that I put in this chart? It should be negative 2. But what am I going to put at that? An open dot. What happens when I plug in negative 2? What do I get? No time. Negative 5. Open dot. A little shaky with this pen. I'm using the one that comes with this computer, which is tough to work with, but actually not as bad as I thought it would be. Then maybe one more point or do slope, but you have to do slope backwards, right? Because we have to go backwards for the domain. So if it's a slope of 2, rise 2, run 1, I can't go forward. I must go backward, down 2, and left to the 1. Left to the 1? Down 2, left 1. And then it's this. Or if you plugged in negative 3, you get negative 7, which is that first dot that I wrote. That's only a little scratchy because of this pen. Yeah. Then I go to the second piece. This is not rocket science. Any student that ever said this was tough, they're wrong. Just pay attention and follow. Should I plug in negative 2? Well, of course I should, right? By the way, where's the vertex for this parabola? Well, I need a coordinate. Oh, 0, 1. And that is in my domain, right? 1 is what I'm allowed to plug in, right? I should really know where it changes direction. You okay back there? Okay, so what fumble? What happens when I plug in negative 2? Negative 2 squared is 4. 4 plus 1 is what? What do I put at negative 2, 5? Open or closed? Major, was that 5? Major jump discontinuity. And then, you could know it's a parabola or plug in negative 1. That's fine. Then where's 1? 1 plus 1 is 2. Ooh, 2. negative 1, 2. And then what is a parabola? No. Isn't it symmetric? This one is even, isn't it? No. And then what am I going to plug in? 3. What am I going to put at 3, though? Open dot. That's the jump off point. 3 squared is 9, 10. I think this only goes to 8. 1, 2, 3, 4, 5, 6, 7, 8. Who do we appreciate? 9, 10. Oops. There's 1 over. Open dot. So here's just this parabola. That's it. Stops. Because it's defined by the domain that's for this piece. Okay, and then the last one. Oh, man. Hey, by the way, what's the vertex of this parabola? What? What's the vertex of this V? Nope. It is. This is written negative 2 minus 1/2 x minus 5. The vertex is going to be 5 comma negative 2. Is 5 part of my domain I can plug in, yes or no? Yes. 5 is greater than 3. So 1, 2, 3, 4, 5, comma, negative 2. You'll see that vertex-like behavior, I probably shouldn't call it vertex, but I did, for this V when we do the other parts. Should I plug in 3? What's 3 minus 5? Negative 2. What's the absolute value of negative 2? You'll get 1. You'll get 1. 2. What's 2 times a half? 1. What's negative 2 minus 1? Negative 3. So, 1, 2, 3, comma, 1, 2, 3. Hey, what kind of V does this appear to be? Upside down. It is a filled in dot because the jump and because this says equal to 3 for this blue part. Couldn't remember that value. And then what do you think that means when I plug in 7? Huh? 2 away, 2 away, huh? Anyone? We can prove it. 7. 7 minus 5 is what? Come on, get this one. 7 minus 5. Come on, get this one. Oh my, never, no, you're done. That's it. 2. The absolute value of 2 is what? Oh gosh. 2. 1/2 of 2 is, what is happening now? 1. Negative 2 minus 1 is negative 3. And then this is what you do. Forever. Right? I have a great question. Holy crap. Are you ready for this? What is the range? Oh my word. It definitely starts with negative infinity.
Negative infinity to 6.
1, 2, 3, 4, 5. So negative infinity to negative 5. And then I'm going to show you what I'm looking at. I'm looking at this graph, and I'm looking at this y value. This is where... Oh, nutcrackers! Right? Doesn't that cover all those that I was gonna exclude? I made a mistake. So negative infinity to negative 2. Nicely done. What do I put on negative 2? Bracket. Nicely done, folks. Nicely done. I got focused on only one part. And then what? You? Me? 1 to 10. What do I put on 10? Parenthesis because it's an open dot. Nicely done on range. I could ask you that as well. Okay, I'm running out of time. I warned you that I was going to reverse analyze this one. Where is it? I can't even find it, so we'll scratch it. I was going to come up with that one. I was going to come up with the equations, but I got to get the video up on